Hello everyone. We have come up with a model basically to talk about how mass and stiffness would impact the building response when they experience earthquake of different frequencies and magnitude. We know that mass and stiffness are the two main variables that would affect the building response to horizontal loads. Let us understand more about it by doing the demonstration here.
In our model, we have the wooden block and different height of the building. So I'm going to generate the output in the wooden block and see how the building responds. So the question arises, when an earthquake occurs, which of the building will vibrate the most? The shorter one, the medium, or the taller one? So most often we will say the taller one. So I'm going to generate the vibration and see how the building responds. So the shorter building vibrates the most. Why not the taller one? This is one type of an earthquake. So the another type of the earthquake is when I generate an earthquake, the tall building vibrates. So the answer is it depends. It depends upon the input motion. This phenomenon is known as resonance. When the frequency of the applied motion is equal to the natural frequency of the building, the motion amplifies. So when I generate the low frequency, the tall building will vibrate. And when I generate the high frequency, the shorter building will vibrate the most.
Now let us understand how stiffness affects the response of a building material. But before that, let us understand what actually stiffness is. Stiffness refers to the rigidity of a material. It is the extent to which a material can withstand the deformation under the action of a force. And stiffness, it actually is related to the height, and it is inversely proportional to the height of the material. Now, if the height of the building increases, then the stiffness of the building, the structure decreases, and vice versa. The stiffness of the building will be more if the height of the building is short. So, let us understand how these things are related to the frequency of earthquake when it strikes it. Now I have an assembly here, and which one would you think will be more affected if an earthquake strikes? Make your own assumptions and let us find out together. Now let me give a slight shake to the assembly here. And as you can see, when I give a very sudden shake, high frequency shake to the assembly, the building with the shorter height is more affected. So this shows that the response of a building, it is directly proportional to the input of the frequency. If the frequency of an earthquake that strikes the place is of a high frequency, then it is likely that the building of a shorter height will be affected more, because its stiffness is more, and frequency of a motion is directly proportional to the stiffness of a material. Similarly, in case of the taller building, if I give a very slight, very low frequency shake to the assembly, the building of the taller one, it is affected more. So to conclude this, the stiffness of a material is directly proportional to the frequency of a motion or strong ground motion that strikes a particular area. If an earthquake of high frequency affects the area, then it is more likely that the material of high stiffness will be affected more than those of low stiffness.
So now we are going to demonstrate the effect of frequency of earthquake on different masses of structure. To begin with our demonstration, we have two metallic rods of same diameter with same height, which means the stiffness of the two metallic rod is same. Now to talk about the masses of the bob, the mass of the blue bob is double as that of the yellow bob. Now we will demonstrate how the system with varying masses will respond to low frequency and high frequency respectively. For the first case, I'll demonstrate when the setup experiences low frequency. So from this demonstration, we observe that for the structure with high masses, when it is subjected to low frequency, it will respond with high resonance. Now for the second case, I will demonstrate when the setup experiences high frequency. As you can observe from the demonstration I have just shown, when the system experiences high frequency, the structure with smaller masses responded with high frequency of resonance. So to conclude from two demonstrations I have shown, we can conclude that the mass of the structure is inversely proportional to frequency of motion.
I'll be concluding about this model, and you must have seen how these different types of weights and heights responded according to different types of frequencies that it is taken with. And when you have seen that, you must have observed that how resonance have effects on these blocks and these thin metal rods. Mass and stiffness are the two main variables that affects the response of building structures, or in this case these models, thin rods and blocks, how they respond to the different types of frequencies that they are applied with. So to tell about the building response or structural response, with increase in height of these thin metal rods or increase in height of the building structures, you will observe a decrease in frequency, and with increase in mass, that is that goes with blocks here in this case, and with building structures, it goes with how huge that building is. With increase in mass, the rate of frequency also decreases.